we are now going to learn how to create the complement of a graph. So the first step always is to import NetworkX as NX. Now I'm going to create a graph. As and always, I'm going to create, let me say G, the graph, to be a random graph, GNM, random graph on, let me say 15 edges, 15 vertices, and let's say 10 edges, 15 nodes and 10 edges, right? Now let me draw the graph. nx.draw G. Do you see that the graph is disconnected? Now let us check the complement of this graph. So GC, let me name it as GC, is equal to NX dot complement is the command of G. Do you see the command here? It is GC equals NX dot complement of G. The complement has got created. Let us now draw GC. So NX dot draw GC. So do you see that this graph is connected? We had earlier drawn a graph G, and now the complement of graph G, which was disconnected, is connected. We had seen this, if you remember, in the previous week, that complement of a disconnected graph is always connected. Now let us move ahead and draw another graph. Let me say, okay, we can also verify one more thing here. Let me say NX dot is connected GC, right? See, it says true. So we have verified what we had seen in the video. Now let me go ahead and let me clear the screen. And now I'm going to create another graph. Let's say I'll create H as NX dot a complete graph on 5 nodes. And I'm going to draw H. You see, this is a complete graph on 5 vertices. Now I'm going to create the complement of this graph as HC is equal to NX dot complement of H. And I'm going to draw it. Let us visualize this graph HC. Do you see that the complement of a complete graph is always disconnected? It is having 5 isolated vertices because we had drawn a complete graph on 5 nodes. So the complement is a disconnected graph with just 5 nodes. It is having 5 components, right? So we cannot generalize that complement of a connected graph is always disconnected. It can be connected to. Let us try that with some random graphs. Now I'm going to draw a graph K as NX.GNM random graph on, let's say, 10 nodes and 10 edges. Now I'm going to draw it NX.draw K. Right? It is disconnected. Let us try it again. Let me say K1 here. Let us draw K1 and next dot draw K1. You see, K1 happens to be a connected graph. Now let us check the complement of K1. Let me name that as KC equals and next dot complement of K1, right? And let us draw it and next dot draw KC. Do you observe this? Complement of a connected graph can be connected to. So this was the graph K1 and this is the complement of K1, KC. So we have seen that complement of a disconnected graph is always connected, and complement of a connected graph can either be connected or disconnected. Now, let us move ahead. I'm going to clear the screen again. So we are now going to see something called the self-complement graphs. If you remember, we had seen that a graph whose complement is itself is called the self-complement graphs. So now I'm going to draw G is equal to nx dot cycle graph. You must be knowing what is a cycle graph. It's nothing but Cn. So I'm going to draw this graph on 5 vertices. Nx dot draw G. You see, I have obtained a cycle on 5 vertices. Now, I'm going to take GC as nx dot complement of G. Now, I'm going to draw GC. Do you see? I have obtained the complement of G, which was a cycle, as again a cycle. Right? Now, here is a nice command what we can use at this time. It is nx dot is isomorphic, and in bracket you can give G and GC, right? True. Do you see that the complement of C5 is C5 itself, and it says that it is isomorphic.